All right, so what's your question? Let me see. Actually, wait, hold on. Okay, let me see.
I got 8 square root 8 minus 8 square root 18. No, it's just 8 square root.
You said it, but like I couldn't picture it in my head.
I've heard some people do exponents.
Yeah. 8 square root 8. Like this.
I don't know what to do with stuff.
So all you have to do is simplify the radicals, right? So square root of 8 gets simplified down into what? 2 times what? Yes. Stupid blue screen. Worse when it's on your computer. All right, so anyway, I have 8 square root 4 times 2, right? Minus 8. How about 18? What does that get broken down into? 9 and what? 2, right? So square root of 9 times 2. And then now what's the square root of 4? 2, right? So this is 8, 2, square root of 2, minus 8. And what's the square root of 9? 3, right? And then square root of 2. So see how I did that? Right?
Multiply
Mhm.
to what it was before.
Kinda. Like I take the square root of 4 to get 2. I said the square root of 9 to get 3. All right. And then the rest of it is straightforward, right? 8 times 2, 16, square root 2, minus 8 times 3. What's that? Like 24, I think. Square root 2, and then you subtract them because they have the same radical and they have the same index, right? So what is it? -8 square root 2, right? Then that's it. Just type that in. That's all it is. Yeah, no problem. Hold on 1 second. Wait, hold on 1 second. My fault. You guys still copying? I'm gonna just do it in blue on the side over here. You said the cube root of what? To the 7 power, like that? And what are they asking you for an answer?
Yeah.
All right, so give it to me as a fraction. What's the answer? No. X to the what power? So fraction power. What is it? A third. What do you guys think? It's a part of that. Like I'm looking for a fraction here. It's a power. Yeah. To the 7/3 power. Very good. That's that.
So wait, the numerator is the one that's not square root.
Exactly. And then the denominator is the square root itself. Yeah, go ahead. Like that? That's not bad. So 64/27 to the -1/3 power, right? So it's negative. So what's going to happen? Where is it going to go? In the denominator, right? So I'm going to rewrite this as 1/64/27 to the 1/3 power, right? And then now, let's take a look. We're raising that part to the 1/3 power. So this, everybody gets the 1/3. So this is 1/64 to the 1/3 power over 27 to the 1/3. Really? You typed in 7/3?
Seven.
Yeah, I did.
Alright, so that's the number. You typed in 7/3? Like 7 divided by 3, 7/3?
Yeah, I did.
So X.
No, just the number, fraction.
Oh, you know the X.
Oh, 7/3, that's it, just 7/3.
Okay.
Yeah. So back to this. What is 64 to the 1/3 power? Yeah. You use a calculator, it's fine. I don't mind. 16 close 4. That's it, right? So this is 1/4 what's 27 to the 1/3 power? Close. 3. Right? And then after this, you want to keep change flip. So 1/1 times 3/4. Multiply straight across. So final answer, 3/4. That's the same as the cube root. A half? How's that a half? Like if you did this?
Yeah, my friend told me it's like the distance was a half.
Oh yeah, when there's no number there, then there's
Yeah.
like an imaginary 2 that's there.
Oh.
But we do have a number there. We have 3.
Like 1/2, 1/3 times.
Mhm. Gotcha. Because we're dividing a fraction, think of this 1 as like 1/1. So change the division and multiplication and flip the denominator. Yeah. And that's it. Mhm. Ra-ba-ba-ba. So anybody else, any questions? Hmm? Okay, like this? So what's that, like 15.5, like that? It's like $16 minus 50 cents, 15.5. Hmm? 15.5, yep. You know what? 97.5? No, you're just minusing it. Like you have $16 and you take 50 cents away.
So the problem is just.
Think so. All right,
Huge. Negative one.
okay.
I got 4 minus 1, I'm not sure.
4 minus 1/2.
Yeah.
So if you have $4 and somebody took 50 cents away, how much you have left?
Usually you have.
-1/2. This is 16 raised to -1/2 power. That's what you say. So 16 raised to the -1/2. Right? So it's negative, so what's gonna happen first? So it's gonna go in the denominator, so it's gonna be 1/16 to the 1/2 power. And then what's 16 to the 1/2 power? Good. So it's just 1/4. That's it. Which one, like 1/4?
No, 3.
Say 3.5 or 3 1/2. Let me
It's a
see.
simplify.
Let me see the question, or tell me the question.
It's not really, help.
It's really pushing me back. Like, what the hell? I got you. Yeah. Good. So you got 4 -1/2, right? So what happens to this with the negative? No. Right? So it goes into the denominator and becomes
Oh, okay.
1/4 to the 1/2 power. Right?
So it's considered an exponent?
It's an exponent, yeah. Yeah, rational exponents, yeah. That's superscript, yeah. So what's the answer here? What's 4 to the 1/2 power? Mhm. Mhm. Let me just see if you can find it. So it's like I'm asking what's the square root of 4. Right? So it's 1/2. That's it.
I kind of do.
In the calculator?
Yeah, I don't know how to do the thirds and stuff like that.
So you press 4, then you just raise it to the 1/2 power. The arrow, hit that, then you just do 1 divided by 2. That's it.
I was just doing it.
That's what that slash means, it's division. Anybody else, any questions? Y'all good? Good. No pressure. Today we're gonna do division. Yay.
You can enjoy it.
Right? Division is math simple.
I just mean like, right?
Got you. Which question you got? What? U/2? Okay. U and 3/2 like this?
Yeah.
Or is it like a big U like? Okay. Like minus or plus in between? U again and then 2/7 like this? Oh, whoops. That's it? I guess it's multiplication and you just multiply straight across. So 3 times 2, 6, 2 times 7, 14. I might be wrong. I feel like I would need to see that question. That's easy. Oh, that's easy. All of this, also all of that, that's the answer.
Today he made us. He made us do. Like says, right? But today he wants to carry to around, so that's twice a day. Right? For 10 days, right?
So, what they giving you this, that's such that hard.
The question.
This question is. Sometimes it gets through John's position, how much people that's when you calculate that, so you can take 40 fingers for each year for the 10 days, stuff like that. It's not wrong, it's just extra. But only with the story. The story tells you that.
This is too. Which you know is ridiculous.
This is just, they're just asking you, how many pills you take at a time.
The guy says, every for 10 days. That's what's confusing.
But they're asking you, like, how much you're gonna take in one dosing, one administration. Like this, right? Like, we're gonna 12-hour shift. Right? So this is what you're gonna get into. And then in the nighttime, you guys gonna do that. Like that.
Okay. So on Monday.
Yeah.
Alright.
Yeah. So everybody's caught up with homework then, because we all quiet. Yeah, I know y'all could work together and stuff. Y'all don't gotta do everything by yourself. All right, so let's jump into the lesson. Today's gonna be mad simple.
Really?
Yeah, real easy. But y'all gotta help me with like these beginning questions. 'Cause y'all know I don't know the math that well, right? How I do this? So kinda. I want to simplify this, right? So I'm trying to reduce it down to simple terms. So what do I do? By 6? Okay, 6 could work. All right, so what's the top gonna be? All right, so 5 times 6 over what's this? 6 and 8, right? And then 6 and 6 cancels out. All right, so I just have 5 over 8. Not bad. Remember how to do this, right? Simplifying fractions and all that. All right, this next one is real hard, real hard. Might even be a test question hard. How you do this? Add the exponents, right? So this becomes x to the 2 plus 4 power, which is x to the 6. Very good. All right, all right. I know I'm gonna get y'all on this one though. This one's gonna be real. We didn't even go over this last class, matter of fact. Yeah, we didn't even go over this. How I do this? Okay. So what you doing? You foiling,
X squared,
right? Not 3x squared. He was right. No, not factoring. Multiply. So 7 times 7, 49. What else?
7 times. Yeah.
Close. Negative 21x. Very good. What else?
Or,
So plus 21x. And then
yeah,
Negative.
very good, right? And then we want to combine like terms, right? So when we combine like terms, negative 21 plus positive 21, what do we have left? Very good. That's it. So remember this, right? All right. Doesn't matter. Yeah, I would take both answers, but technically speaking, you're supposed to do it in descending order. You know, highest power to the lowest, that kind of thing. Yeah. Yeah. But for me, like I'm cool. I know what you mean. So this is what we're gonna get into today. All right. No surprise. We're gonna divide radical expressions. Good stuff, good stuff, good stuff. Right? So we have used the quotient property of radical expressions to simplify roots of fractions. We will need to use this property in reverse to simplify a fraction with radicals. We give the quotient property of radical expressions again for easy reference. Remember, we assume all variables are greater than or equal to 0 so that no absolute bars are needed. All right? This is how we doing it. This is how we doing it. This is how we do it. Nice stop. All right. Y'all know I like to repeat myself, right? So the quotient property of radical expressions, if the nth root of A and the nth root of B are real numbers where B cannot equal 0, and for any integer n greater than or equal to 2, then we have the nth root of A over B is equal to the nth root of A over the nth root of B. And the reverse, the nth root of A over the nth root of B is equal to the nth root over, the nth root of A over B. All right? Yeah. You don't understand it? I'm not gonna lie. I was thinking about giving it to y'all on your next test. You know? Like no, I mean like giving you the formula so you ain't gotta memorize it.
It's the first thing, problem just went over that those were hard.
I'm trying to think. Nah, those won't be on this test. I don't even think those will be on your final, to be honest. Yeah, the first 3. Yeah. All right, so look, we will use the quotient property of radical expressions when the fraction we start with is the quotient of 2 radicals, and neither radicand is a perfect power of the index. So when we write the fraction in a single radical, we may find common factors in the numerator and the denominator. So long story short, right? You have a radical or a root, whatever, right? That's gonna have the same index, right? It's like a same index divided by same index. We write it under one root, right? One root. And when you do that, you can simplify the inside, just like we did in the first question, right? Give me an example of what I'm talking about. So check this out, check this out. So let's say I have A and B right here, right? Make that a little bit bigger so that we can see, right? So I have the square root of 72, x to the third, divided by the square root of 162x, right? So what I'm saying is for A, right? Rather than have two separate square roots, I could write this under one square root, just like this, one big square root. And then I just do 72 x to the third over 160, hold on, 162 x, right? And then now I can reduce the inside of it, right? It reduced the fraction on the inside and leave the radical. So help me out. 72 over 162. What does that reduce to? It's okay if y'all don't know. Y'all could just do something simple. Y'all could chop it in two if y'all want. I'm down for that. 13? Oh. So let's do numbers with numbers, variables with variables, right? All right, so 72 over the 162, right? Reduce that, simplify it. What does that become?
Okay, that's 6 squared,
Yeah.
6, for 6 squared.
6 square root 2, no. All right, I was thinking something simple, right? I was thinking like, I don't know. That them tests must be real over there. They losing it. They losing it. I always tell them just choose B when they on the test, but like, nah, they stressing. All right. So I'm looking, wow. Okay. So I'm looking at 72, right? And I want to chop that in two. Right? So what's half of 72? 36, right? So I'm thinking 36 times 2, x to the third over 162. Chop that in two. What's that? 81, right? 81 times 2x. You see how we have the common factor of 2's right there? They cancel out. So now what am I left with? I got 36 over 81. I have the x to the third divided by the x. What does that become? X squared. Now, you see, now we're talking. Now we're talking. Good. Right? But now I could take that radical individually. You see how everything just kind of simplified down for me a little bit? Right? So now I could do the square root of 36x squared divided by the square root of 81. Right? So what's the square root of 36x squared? 6 what? 6x, right? Over what's the square root of 81? 9. I could go even further than that, right? Reduce that out. Right? So this would be 2 times 3 times x over 3 times 3, right? Common 3's, cross that out. Final answer, 2x over 3. Light work, right? The point is that sometimes, even though the question started off like this, right? You could put them under the single radical, reduce it, and then do your square root. You know? Sometimes that's easier to do. Right? Let me grab B real quick and try B out. There you go. So all I'm really doing, I'm just finding like common factors and I'm just knocking them out. Bam, 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 bam. That's it. Real simple. Mhm. Yeah. It's like this. Yeah. Yeah, I know. No, they got a test next door, so they probably stressing.
Nobody in the front door.
Nah, they in there. They in the front. You know.
But I went to my man in truck driver.
He dropped.
So,
Yeah. He was a man though, man. But like he was cool, you know.
yeah.
But you know what it is too. Like you know when you working in the day, and then like to come to class, and then you have to study and all of that. Yeah. Um, yes. Reduce the X's as well, and then you should be able to work with it from there.
Just tomorrow, nobody's coming in because they're like, see how it goes, they're low. So like, you can't really do your job, so you may have to make up your hours. I'm like 9 to 5, to then to 6. Then we
Wow.
go to class. It's like, all right, we'll find something for you to do. Like I said,
Honestly, I would rather go remote, but
yeah,
y'all know.
nobody be doing nothing. We're still working, we're just at home. Like, yeah, okay.
I mean, remote is fire. It looks just like this. Hmm? Yeah. Because what I'm doing, I'm just simplifying the radical. Yeah.
Last Sunday's line, it's like, call me if you need me, because I was in person and they were remote. I called nobody else. I'm like, yeah, here on vacation, some stuff up there working remote. Like,
You could do that too. That's legal. All right, let's try out B real quick. B's massive. My fault. I didn't line up everything correctly. So for B, right? I got the cube root. That's a 3, by the way. 32x squared. Let's see. Over cube root 4x to the 5th power. Uh-huh. So what I notice is that they both under the same radical, right? With the same index, index 3. So what I could do is write this as a under a general big radical, just like this, boom, right? So now I have 32x squared over 4x to the 5th. Now what you do, simplify the what you call it, the fraction inside, right? So 32 divided by 4, what's that? Remember, numbers with numbers, variables with variables. Yeah. Yeah, makes it easier. It's 8. All right. Yeah, it is. All right. And then now help me out. X squared divided by x to the 5th is x to the what power? Close. To the 5th power. No, huh? Say it again. Yeah, right. Subtract the powers, right? Exactly. All right. So this becomes the cube root of 8x to the -3 power. Right? Well, actually, yeah, I'm gonna do that right now. All right. So because it's a negative exponent, you know that this is gonna go into the denominator and become positive. So now individually, I can take the cube root of both, right? So what's the cube root of 8? Nope. 2, right? It's 3, right? So this is 2. And what's the cube root of x to the third? That's it. That's the answer. All right. Just showing y'all a little strategy. Mhm.
I know.
Well, this is a way not to find it. Reduce the fraction on the inside and then just do the simple stuff that you know. Yeah. Right.
So, and reducing it.
Mhm.
So you did it
Mhm.
top, you can't, you didn't divide the 72.
Yes, I did.
You did?
I reduced that. Yeah.
Yeah, the 36.
Yeah. That's how I got the 36 and the 81.
162 divided by
2. I just cut them in half, divide them by 2.
Oh,
Yeah. Whatever number you reduce it by on the top, you have to do to the bottom. Yeah, so they got to be the same.
what is
Yeah.
it? So,
Then they can't be reduced. Yeah.
what if I-
Then do it if you can. Yeah. Yeah. As long as it's the same number for top and bottom. Yeah. The 2 over x. So individually, I did the cube root of 8, which is 2, and then the cube root of x to the third power, which is just x. Yeah. It just leaves it. Good? It gets easier, I promise. Yeah, this,
Even they can test for something fast.
I mean, multiple choice would be hard, though. I ain't gonna lie.
I need my chance. I wait, we said, we probably won't get no points for trying.
Nah, no, none of that.
I'd be lucky sometimes.
But it's the same questions though. No lie, the questions that we do in class are harder than the ones on the test. Like for example, I'm not gonna ask you like, what's the cube root of 56 on the test? You know, like my timetable stop at 12. You know, like that's all we gonna do. So you guys try this with S's and A's.
You know, half.
Mhm. At half it, you see how it ended in 2? That's what made me half it.
Right. That's,
Mm.
that's why, that's, but what,
Yeah.
If it ends up two.
It was because it was even, yeah. I'm not sure. I'd have to do the tree on both of those. Yeah,
oh,
yeah. That's what happens when you know your timetables. For the same number. Yeah.
this is the requirement.
This is simplifying no, excuse me, dividing radical expressions. I think the homework is posted for this. You guys could take a look. The homework is even easier than what we're doing in class. That's the sad part. I think the homework is like 20 questions. I could take a look. So yeah, we need to catch up on homework soon. No, we only got 2 more weekends left before the final. Right? August 1st. Yeah. No, August 1st. No, we have another test. Yeah. No, next week Thursday.
That's fire.
Yeah. It's not gonna be that bad. Yeah,
Finals gonna have everything on there, right?
everything. Yeah, from day one. Yeah.
My name's inside.
Nah, but we gonna prepare for it though. Some of every subject. There's gonna be a lot of stuff that's skipped. 20? Yeah. You have like 2 hours. But it'll be good though. Yeah. It's way easier than all this stuff. Yeah.
We're gonna have like Python square, something square.
Stuff like that, yeah. Simple stuff. Yeah. Nothing crazy, like no 15 times 6 kind of nonsense. You know? Simple math.
It's crazy. My math teacher, third grade, just remember that stuff. I only remember one. It's 15 times 15 is 2 days.
Right? I remember that one too, yeah. My issue was that like when they got to this point where it was like, all right, what's 13 times 2? I'm like, I don't know. You know, it ran over my timetables. And then they showed me how to do it individually, like 3 times 2. And then, like once they showed me that, I'm like, why am I memorizing this? I can figure this all out. Like, you know? All right, let's look at A real quick. You stuck? No? 4? Well, let's see. The first thing I want to do, right? I want to write this under a big square root. So I have 50 s cubed over 128 s, right? So let's break this down. You want to break it down by 2? All right. That's what I would do too. Yes. So s to the third divided by s is what? S to the second. Very good. Right? And I'm just gonna kill this by 2. So what's this? 25 times 2? And then what's this one? 64 times 2?
Yeah.
Something like that. Then these cancel out. So what do I have? I have square root 25 s squared divided by 64, right? And look at those. Aren't those all perfect squares? So let's do them individually. We have square root 25s squared over square root 64. Help me out. 25s squared, what's that? 5 what? 5s, right? Over what? 8. That's it. Done. So I cut the 50 in half, 25 times 2. Then I divided out the 2's in the second.
Oh, that's that.
Yeah. My fault. Yeah. Oh, you tried 3 first? Oh, but 3 is even easier. Yeah, let's look at 3. So I'm gonna do this in purple. So for 3, right? I mean B. What am I saying 3? I just learned my alphabet yesterday. So we want the cube root of 56a divided by the cube root of 7a to the 4th. So let's write this under one general root just to make our life easy, right? So I'm going to do the cube root of 56a divided by 7a to the 4th, right? So let's reduce this. 56 over 7, what's that? 28.
We're having a story.
What's 56 divided by 7?
Oh.
Yeah, it is. Wait, is it? Yeah, it is. Yeah. So now, I was trying to do it in my head. So now I have a divided by a to the fourth. What does that become?
It's in the -3, so.
A to the -3. Very good.
8.
Good. So this is going to become cube root of 8 over a to the third. And then help me out. What's the cube root of 8? Good. And the cube root of a to the third? A. So this is just 2 over a. Simple, right? Yeah.
It's subtracted harder.
We did that already. Yeah. It's like, so with the addition subtraction, remember they have to be the same, right? Same index, same radicand. Then you can add it or subtract it. Yeah, but if they're different, you just leave it alone. Like don't touch it. Yeah. And then for multiplying, you just multiply the outside numbers, coefficients with the coefficients, and the radicands, the stuff on the inside with the stuff on the inside, as long as they have the same index. Right? That's it. Yeah, come through. Yeah. I mean, you could, what you call it, go to tutoring mode if you want. Yeah, yeah, remember? Yeah, we had it. Yeah, yeah.
Well, I could, but it's only like an hour. But I was gonna come today. I went to the store to get a sandwich. Tells me the
Gotcha.
car machine don't work. I'm sitting there
Oh,
for 20
Lord.
minutes. It's 5:20. I'm like, I gotta go back to work to get my stuff.
I
This is
feel you.
bad.
I feel you.
I'm hungry.
I feel you. All right, so this is what we about to do next, right? Over here, we want to rationalize a one-term denominator. All right. So before the calculator became a tool of everyday life, approximating the value of a fraction with a radical in the denominator was a very cumbersome process. Yes, it was. For this reason, a process called rationalizing the denominator was developed. Okay, a fraction with a radical in the denominator is converted to an equivalent fraction whose denominator is an integer. So square roots of numbers that are not perfect squares are irrational numbers. When we rationalize the denominator, we write an equivalent fraction with a rational number in the denominator. This process is still used today and is useful in other areas of mathematics too. Long story short, it is illegal to have radicals in my denominator, right? The radical is like the hat thing. Like, see how we have cube root of a right here? That's radical, right? So, because it's illegal, what we do is we rationalize the denominator to get rid of it, right? This is definitely on your test. Definitely on your test. So this is how we do that. Clicked on the wrong thing. But before we do that, because I know somebody wasn't listening, tell y'all again. Rationalize the denominator. So rationalize the denominator is the process of converting a fraction with a radical in the denominator to an equivalent fraction whose denominator is an integer. All right. Make sense? All right, since you shook your head no, I'm gonna say it one more time. All right, one more time. Got you. All right. So even though we have calculators available nearly everywhere, right? A fraction with a radical in the denominator still must be rationalized. It is not considered simplified if the denominator contains a radical. Similarly, a radical expression is not considered simplified if the radicand, if the radicand contains a fraction. All right. That being said, simplified radical expressions, all right? So radical expressions considered simplified if there are no factors in the radicand have perfect powers of the index, no fractions in the radicand, right? No radicals in the denominator of a fraction. All right? It's so important, I repeated it a fourth time. Yes. No, can't have that. Right. We have to reduce it, right? Each and every time. All right, so over here, to rationalize the denominator with the square root, we use the property that the square root of a squared is equal to a. If we square an irrational square root, we get a rational number. All right? That's good to know, good to know. All right? Don't copy these, this will probably be a test question. All right? So we're going to simplify
Oh,
these three right here. All right? I'm not going to lie, A is the hardest one out of all of them. All right? Sure, you can say that. So look, for A, right? I have 4 over the square root of 3. So it's illegal for me to have radicals in my denominator. So I'm going to rationalize this. This is how I rationalize it. All right? I'm going to multiply it by another fraction where it's going to be the denominator over the denominator, kind of like that. So I just copy what's in my denominator, write it over to another fraction, and what I do to the bottom, I do to the top. That's it. And then what do we do after that? Multiply. And how do we multiply fractions? Straight across, right? So what's the answer?
well,
So for radical 3 over radical what? No, radical what? Right. So radical 9, right? And what's the square root of 9? 3. So this is my final answer. 4 square root 3 over 3. Right. If you want to go so far and just write down 3, I'm happy with that. I'll take that. Radical 3 times radical 3 is just positive 3.
That's
I'll take that. Yeah. Right? But that's the process of it. Simple, right? No, I need that. Yeah, that has to be there.
multiply regular number by the radical.
No, you just write them next to each other. How about B? B doesn't look too bad, right? This is square root 3 over 20. So from the last example, right? What are we gonna do? Not reduce it. I'm gonna put it over the radical individually. Radical 3 over radical 20. Right? Now you have two options here. You already know what's gonna happen, right? I'm gonna multiply it by radical 20 over radical 20. Or you could reduce the radical 20 and then multiply by the radical that's there. Which would you guys like to do? The second one? All right. So honestly, just to multiply by the 20. So if I'm gonna reduce this, right? This is gonna stay radical 3, but radical 20 gets broken down into what?
5.
Square root 4 times 5, very good. And the square root of 4 is what? 2, right? So this is square root 3 over 2 square root 5. Now the 2 is legal. The 2 could be there. But that square root 5 can't be there, right? So what am I going to do? I'm going to multiply by the square root of 5. But what I do to the bottom, I got to do to the top. Just like that. And then now, how do we multiply fractions again? Straight across, right? So what does this become? What does that become? Radical what?
Oh, we added.
Multiply. What does it become?
So it's
Square root of 15 over what?
over like
two
five times five.
radical, what? 25, right? And the square root of 25 is what?
Five.
5, right? So this becomes square root 15 over 2 times 5. And what's 2 times 5 again? 10. So this is square root 15 over 10. Done. You don't like this one?
This one seems longer, but the same thing.
Yeah. So if we did the 20, well, 20, right?
Yeah.
I would have had what? Square root 60 over 20. And then square root 60 would reduce down into what? 6 times 10. Yeah. It would have still came out to the same answer, right? It's just that I'd have to reduce it at the end. Yeah. But you now know the secret. You could do either or, right? I want to take a look at C now. C looks like it might be a little bit harder, right? Because it got an X, but it's not.
The first one was the hardest.
Yeah. It looks like it's harder, but it's not. So what am I going to multiply this by? I want to get rid of the radical denominator, right? So square root 6x. What I do to the bottom, I do to the top, square root 6x. Multiply straight across, what do I get? Say it again. It's 3 square root 6x over what? You could literally just combine them and tell me 6x, if you wanted. That's legal.
36. 36.
Yeah.
But
But if you wanna go do that, all right, 36x squared. And then now when we reduce it, I have 3 square root 6x over, what's this? 6x, right? The square root of 36 is 6, square root of x squared is just x, right? We can reduce these numbers in front though, right? 3 goes into 3 once, 3 goes into 6, what, 2 times? So final answer here is actually square root 6x over 2x. And that's it.
How you know to do that though? I wouldn't remember that, I don't think.
That's what I got. I might give you credit for that. Yeah, I'm not like really a stickler for that. But technically speaking, you're supposed to reduce it down to basics, like this.
The right hand, that's why you can do 3 goes into 6 twice.
Mm-hmm. You guys try. That's what I was saying. I was thinking about giving y'all this. Try those out. When is this?
But,
Oh, but just the whole number 3 on the bottom, and then that's it.
oh, so you have
Yeah.
to square root the bottom.
Yeah, yeah.
Oh,
Uh-huh.
so for
Mhm.
32,
Mhm. Mhm. No, perfect square. Perfect square.
oh,
Mhm. Wait, no, you said 16 times 2? Yeah, that's fine. Yeah.
oh,
So 4 square root 2. You can leave 4 alone, just square root 2. That's the part, the bad part. Yeah, 4 on the outside. Yeah, yeah. Yeah, that's the problem. It's the square root 2.
wait.
As long as you got it reduced. Yeah, yeah. Right. Mhm. Well, actually, I don't care if the radical is in the numerator, just as not in the denominator. Yeah. Mhm.
It's not the first one, it's the second one too, or that's the.
You use the same process for. All right, let's take a look. So looking at A, right? I have 5 over square root 3. I want to rationalize this denominator, so I'm going to multiply by what? Square root 3 over the square root 3. All right, what does this equal? Okay, very good. That's it. Questions? Are we good? All right, let's look at B real quick. So I have square root 3 over 32 equals what? Uh-huh. Very good. Very good. Well, you say 4 square root 2, right? And then, so multiply by square root of 2 over square root of 2, right? So basically, just take the radical, and that's what you're going to multiply by. The same thing. What you use the bottom, use the top. And then after that, just multiply. Yeah. So what's square root 3 times square root 2? What's that? Exactly. So it's going to be square root 6 over what's square root 2 times square root 2? So this is gonna be four, what? Square root of 4. Good. Oops, sorry. I meant to do that. Questions on it? Can it be square root 2/2? Oh, how I got that?
Yeah.
So I take the radical that I have here, and then that's what I do. But what I do to the bottom, I gotta do to the top. Let's see. So 2 over square root 2x. All right. What do I do here? Good. Square root 2x over square root 2x. All right, multiply what? Straight across? So what do we have? Good. Twos will cancel. Final answer. That's it. Sure. Letter B. This. This thing. You're welcome.
What was the question you had on the next?
Yeah. In the final. Yeah. That this topic for sure will be there. All right. Here's the next thing that we're doing, right? So we did one term in the denominator. Let's do 2. All right. So we want to rationalize a 2-term denominator. Now, when the denominator of a fraction is a sum or a difference with square roots, we use the product of conjugates pattern to rationalize the denominator. So a minus b times a plus b is equal to a squared minus b squared. And 2 minus the square root of 5 times 2 plus the square root of 5 is just what? 2 squared, right? Minus square root of 5 squared, or 4 minus 5, which is -1. When we multiply a binomial that includes square roots by its conjugate, the product has no square roots. Okay? Let's take a look. You're done? Oh. One second, you guys. No, take your time, take your time. All right, let's take a look at this. All right, make this a little bit bigger. All right, so I want to simplify 5 over 2 minus the square root of 3, right? So I'm going to multiply this by its conjugate. What's conjugate mean again? Opposite. So what's the opposite of 2 minus square root of 3? 2 plus square root of 3. But what I do to the bottom Got it to the top, right? 2 plus square root of 3. And how do we multiply fractions? Straight across, right? So what does this become? It becomes 5 times 2 plus square root 3 over, what's this? 2 minus square root 3 and 2 plus square root 3. Uh-huh. So what do I do after that? Yeah, I would say we're gonna multiply it, right? Yeah, multiply it. So 2 times 2, what's that? 4 plus 2 square root 3 minus 2 square root 3. And this is gonna be minus 9. Right? Hold on. Square root of 9. Nope, it's 3. All over. Let's distribute this. 10 plus 5 square root 3. Combine like terms, what do we have? We have 10 plus 5 square root 3. 5 was, yeah, that was already there in the original, the 5. Yeah, we're using it again. Exactly. Because 5 times square root 3 is 5 square root 3, because we can't combine it. Yeah. So now, 10 plus 5 square root 3 over 1, right? So final answer is just 10 plus 5 square root 3. That looks good. Questions? Multiply by the opposite, top and bottom. That's the sauce right there. Just foil it. That's it. You guys try. I just want to check something though. Like, everybody here, y'all been getting the announcements or at least emails about the announcements? It's good. None of that? At the classic, let's try some. One in five. It is. This is actually the hardest topic for today. So I'm gonna multiply this by what? Plus, right, square root of 5. What we do to the bottom, we do to the top. 1 plus square root of 5. All right? Let's distribute the bottom. What am I gonna have? 3 times 1 plus square root of 5. What's that? 1 times 1, 1. Plus square root of 5, minus square root of 5. And then minus, well, let's say minus 5, right? Square root of 5 times square root of 5. Right? And then these will cancel out. I have 3 times 1 plus square root of 5 over 1 minus 5. What's 1 minus 5? -4, right? So what does this become? This becomes 3 times 1 plus square root of 5 over -4. Reduces down to what? I would take this as an answer, to be honest. But if we're going to be politically correct, it should be like this. 3 times 1 plus square root of 5 all over 4.
Oh, the negative. Outside.
Yeah, yeah. I would take any one of these as an answer. So I leave it up to y'all, however y'all would want to do it. Hmm? Because I want to reduce it, so I can leave it like that. If you want to distribute it, be my guest. But you can reduce that. Like you can leave it as this because it's reduced. Yeah. I feel like it's easier to just put them next to each other. You know? Just showing you options. You know? Lost? Got you.
If I would have to, to begin on this.
I can. I just put the negative on the outside.
Oh, so both of them.
Yeah. Any one of those I would take. Whichever one you want to give me. All right. So now if you guys want, y'all got laptops, y'all could take out and start your homework. I have more problems to go over, but it's the same thing. So pretty much the rest of the class is for my enjoyment. All right. Like this question, for example. What fun. Y'all gotta try it. So look at this. I got squirrel. Yeah. It looks crazy, but I promise you, it's mad simple. I'm gonna multiply this by what? Exactly, right? So what is it? Not minus, plus. Excellent, right? And what I do to the bottom, I do to the top. And that's it. Straight up. That's it. So distribute them. Mhm. Let me see. Square root u plus square root what? 18 divided by what's that? Square root u times square root u is just u. All right. Square root u times positive square root 6. It's gonna be what? Positive square root 6u. Negative square root 6 times square root u is gonna be what? Negative square root 6u. Easy, right? Negative square root 6 times positive square root 6 is just what? It is square root 36, and square root 36 is just 6, right? You already know we're going to cancel these out, combine like terms. So what do I have now? I have square root of u plus square root 18 divided by u minus 6. No, u minus 6. Square root of 18 could get broken down a little bit though, right? I feel like that could get broken down into square root of 9 times 2. So like square root u plus what's this? Square root 9 times 2 over u minus 6. So I feel like I would take a final answer of square root of u plus 3 square root 2 all over u minus 6. And that's it. Not bad, right? Just kind of putting everything together with it. And that's not even the fun question yet. Wait and see, wait and see, wait and see. Here, you guys try. A little bit easier, right? You got a 5 and a 2. Not too bad. Oh yeah, that's the fun question. Fun question coming up next, right after this. It's about to be lit. Wait till y'all see. Wait till y'all see. By the way, when all y'all is in Math 30, I hope y'all come visit me. I'll be in the tutoring lab. Love to hear about your adventures in Math 30.
So then we should bring some of that.
Is broken over there?
Yeah, the broken. Yeah.
Oh, yeah. I mean, Meister, they got the good stuff over there, you know?
Yeah, I gotta say, I think
Gotcha.
it's something.
They got some stuff over there that's like kind of frozen-ish. Then you can like
Yeah.
microwave it over there.
Oh, the frozen.
Oh, got you.
It'll be as,
Yeah. Yeah, one of those days.
There's a crazy lady too. I'm not sure if she's crazy. She got Tourette's or something, but she was like,
Oh man.
I seen her in the gym before. She was going crazy. She was just
On campus or
on campus. She was like,
wow.
"Brrr," she just screaming like a maniac. And then
Man,
outside, I walk out my job to go to deli.
yeah.
Like, I don't like when Hispanic people hit on me. I'm like, whoa. I
Yeah.
didn't even say that, but she started cursing everything.
Wow.
Then she just chilled out for a second. I
Yeah.
was like, oh, she got some. Yeah, freaking the hell out.
Today I was thinking about the deli, but I'm like, dang, man, to make that travel over there.
Yeah, I was thinking about going all the way down to the chicken spot, but I was like, I'm wearing all black.
Is it the Texas one?
Yeah,
That's a deep walk.
it's not that bad, but I'm wearing all black. I'm dying.
If you really, really, really want to invest time, if you go like the next block over, they got wing stock.
Oh yeah, I know about that.
Yeah. In past the train, like maybe a block up. Yeah, wing stop.
But like the locker,
Is it Foot Locker?
is like
There was a Foot Locker a
it's
long
like a
time ago.
JD or something.
Yeah.
It's like,
Yeah, right down there. Yeah. They're not bad though. I used to eat at that wing stop all the time.
I ain't really get to this stuff because they like some real ass weed.
Ah, the tenders is fire. Yeah.
It wasn't one of those.
Dang.
It's crazy.
Now you know who got some little wings is Popeyes.
Oh yeah,
Yeah. Yeah. Like Popeyes wings feel like I say this now, like you know if you like over fry something, like the
Yeah,
burnt
yeah.
part, and you just like yeah. Nah, what I wish that Popeyes would make I wish that they would do blackened chicken. Just straight up like grilled chicken for tenders. But I mean like chicken on the bone, like just straight up grilled chicken. Like that would be so fire. Yeah. Yeah. I feel like that would sell out. Yeah. Cause like I like their seasoning, but I like their seasoning on the chicken, not the breading. You know, like yeah. All right, so let's try this real quick. What am I gonna multiply this by? Exactly, right? So this is gonna be square root of x minus square root of 2. But what I do to the bottom, I gotta do to the top, right? So square root of x minus square root of 2. So you already know, right? Distribute, all that good stuff, right? Bam, 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 right? Let me erase these arrows so it makes more sense. So square root of 5 times square root of x, this is square root 5x. Minus square root of 5 times square root of 2, this is square root 10. All divided by square root of x times square root of x is just x. So square root of x times negative square root 2 is negative square root 2x. Square root 2 times square root x is going to be, that's supposed to be x, plus square root 2x. And square root of 2 times negative square root 2. What's that? Negative 2? Negative 2, right? Combine like terms, you already know these going to cancel out. Final answer, square root 5x minus square root 10, all divided by x minus 2. That's it. Simple, right?
The one I had trouble with is the big time.
The big one? That's not too bad. But hold on. We ready for the nice question now. It's about to be lit.
Close one.
Nah. This is lit. And it's exactly what you think I'm gonna do. It's exactly what you think I'm gonna do. There you go. Fire, right? So square root of x plus square root of 7 over square root of x minus square root of 7, right? Now check this out. The numerator is legal, but the denominator is illegal. So what am I gonna multiply this by? Exactly, right? The conjugate of the denominator. But what I do to the bottom, do to the top. Square root of x plus square root of 7. So what's that going to be? All right, so I have square root x squared. I'm going to do this step by step just because we got time, right? Plus square root of 7x. Now we're talking, right? And then what's the next one? Plus square root 7x. Very good. Right? So think of it like this. They're in parentheses, right? I'm just foiling them. That's all I'm doing. And then square root 7 times square root 7, what's that? Plus square root 49, very good. All right, let's do that on the bottom. Let's do it on the bottom. Square root x times square root x, what's that? Square root x squared. Square root x times positive square root 7 is what? Square root 7x, very good. And then negative square root 7 times square root x is what? Square root 7x, all right? Now, negative square root 7 times positive square root 7, what's that? Negative square root 49, right? All right. Let's combine like terms, simplify all of that in one, right? Square root x squared, what does that become? X, right? And then plus square root 7x plus square root 7x plus, what's the square root of 49 again? 7, very good. Over square root x squared is just what? X, right? Plus square root 7x minus square root 7x. And then minus, and then square root of 49 is what again? 7, right? Let's combine like terms. What does this become? I have x plus what? Say it again? No. What's square root 7x plus square root 7x? No. Square root 7x plus square root 7x. Yeah, what is it? Oh. They have the same radicand and the same index, right? So we can add them. So what do they become? No. All right, let me give y'all a hint. What does it become? Positive what? No. How many of them is there? So what is it? No. No, add. Yeah. No. We're adding the square root 7x and the square root 7x. What does that become? 2. Yes. 2 square root 7x plus 7. It's all right. I was like last week. Right? And then the bottom we know this is positive square root 7x minus square root 7x that cancels out. X minus 7. That's lit, right? No?
Did it change to a ration?
Mm-hmm. That's it.
Oh, man.
You guys try. I think this is dope. I think tonight supposed to be the Republican convention or something. Should be something to watch.
Yeah, we need to acknowledge from this.
Right? It's crazy. Yeah. Maybe. He should technically be wearing a bulletproof vest. The ex-president.
I don't know.
I don't know.
It sounded like you,
It did?
and if it was like,
Not kill someone.
they don't wanna say that, you know,
Yeah,
like, they
yeah.
don't wanna show like,
Mhm.
they obviously show.
So somebody said that like like if he was just like a podium talker like this, like he'd have been out.
Yeah.
But because he'd be like, like,
Didn't come forward.
no, it was from behind. It was like, yeah. So it's the people in front that got shot, not the one in the back. They were safe. Yeah. No, one person died.
I think two people.
Yeah. This guy, he was like a firefighter. Like he hopped on top of his family and took the bullet. He died. Yeah. Yeah.
It sounded like you, I don't think.
It might have had a silencer on it.
Yeah, I think it was the rifle.
Yeah.
Rifles don't make loud noise, you
Yeah.
don't hear it.
I heard it was an AR or something or
Yeah,
whatever.
rifles don't make
Yeah.
they sound like.
But you know what I was telling someone though, right? Like they say that the ARs are supposed to like be more accurate, but it's only accurate if you know how to make it accurate. Like, yeah. No, but the thing is that like this dude is not a professional.
Yeah.
Like Yeah, you know,
It was bad.
like he had like maybe what 100, 200 hours of Call of Duty and thought he could do something. You know? Yeah. Allowed to.
I think it's just funny though. It's just like I don't know.
They had-
you up to something, man.
They had this big dude came on TV, said that dude used to bully him. I was rolling. Yeah, I was rolling when I saw that. I was like, why too?
Like he was just
Yo.
he's just played it off now.
Nah, but real talk though, Trump made me mad when like right after he got shot, right? Like the whole thing, right? So first off, he got shot, right? And then my man like checked his ear, like the reaction time was mad slow. You know, yeah, like to me, to me to me his reaction time was slow, but I got to give it to him because he is like what 82 or something, like he up there in age, you know. So all right, he went down slow, right? Like after Secret Service tackled him. Why when he gets up, he's like, "Yo, let me get my shoe. Let me get my shoe." Wait.
Yeah.
Dude, like, did you?
Chain.
They literally just shot at you, and you gonna open yourself up like see me here. You missed. Like, yo, and the thing is that he did it twice. They get to the staircase, and my man is like,
He did it again?
yeah, he did it twice. Right, that's where they got the iconic photo with the
Oh,
flag in the back of him and all that. That's the second one. Yeah, and then he did it the third time when he got to the car. Right? I was like, yo, I'm like,
So why did he go ahead?
yo, and they over here huddled trying to protect him, and my man's gonna raise a hand like I'm right here, like yo, yo, yeah, that was a good picture. Yo, the amount of t-shirts I seen with that joint, mad quick, yo, mad quick, yo.
I think it's funny though, like it's definitely a liberal shot.
Right? Oh man. Yo, but I heard that somebody in the crowd said that they saw a dude climbing up there and it was like, yo, look. And Secret Service was like, uh-huh. It was like, yo, y'all don't see that?
It's just like
Yeah.
Like maybe they thought that he was just trying to like have a better view. Like, let me zoom in. USA.
And they had snipers, so they probably like. Does have, but they have snipers. There.
Yeah, they took him out. Yeah.
Heard three.
Mhm.
We heard three shots. I think they moved about one.
Or like, you know how when you watching a movie and then like somebody gets shot and then like they're dying and they're falling, but it's like the gun is still rushing. So yeah.
like the savior. One of them's gotta go. We gotta eat with our kids. So.
I don't know. This is crazy.
I don't even like Trump, but like I see someone like, yeah, he should have died.
What if he did though? Like what would happen in the end of the year?
Trump supporters are like
Word, Biden would probably just be default. Because who's gonna yeah. Yeah.
Trump people like, oh, we'll probably kill Biden.
Trump didn't even have a running mate yet.
No.
So it'd have been who, you know? I heard today, right?
Just a
Yeah,
random
I don't even know who that is.
Yeah, nobody knows.
Yeah, I gotta Google them. Yeah,
Did they say his name?
JD something. His first name sound like a law degree. Mm.
Okay.
Yeah. Yeah, no, like the law degree, because like when you get your Juris Doctorate, right? Your name becomes the JD at the end,
Oh.
Yeah.
Now,
Right. Like a doctor of
Yeah.
juris or whatever. Yeah.
You have your
Yeah.
doctor?
Ah,
Oh, man.
one day,
They be
one
weird.
day.
They're like,
Yeah.
I'm a doctor. I'm like, you're not a
I know
doctor,
some
man.
people is like serious about that,
Actually,
like yo, right?
I
I know some people is like yo.
don't want you to know I'm about to get sick right now.
Actually, you know what? I had one professor. He used to go to the doctor and he used to be like, I can write my own prescription though, right? Like, nah, he was joking. Yeah. All right, so let's look at this. Square root p plus square root 2 over square root p minus square root 2. What am I gonna multiply this by? Square root p plus square root 2, right? Conjugate. You want the opposite of the denominator. What I do to the bottom, do to the top. Square root p plus square root 2. After that, you already know what to do. Just FOIL it, right? Say nothing. Square root p squared plus square root 2p plus square root 2p plus square root 4 over what? P squared, good. Minus square root 2p plus square root 2p minus square root 4. Good. All right, which will be 2. So now let's simplify this. What does this become? Plus. Okay, I'll take it. 2 over what? Square root of p squared is p minus 2. I'll take that. These two cancel out, and then minus 2. And then that's my final answer. Easy, right? Yeah.
I get the full picture.
Yeah. Awesome, awesome. All right, everybody copied it? No? All right, go ahead. So that's it for tonight. Take out your computers, do your homework. Mhm. Let's catch up on our homework. All right. We got 2 weeks left until the final. Next week is test 3. All right. Huh? Yeah, I didn't do it yet. That's my fault. Yeah.
He's gonna give us
Uh-huh.
100. He'll feel like great.
Yeah.
Okay,
Yeah.
Honestly.
I did so many, but I did it by myself. So I don't even
Gotta
know.
go with 2 to
I went to tutoring,
Yeah.
but I have to do it.
get their signature.
Oh,
Yeah. Just
I was
come
like, oh,
when you got time, just come through.
Yeah, I'm gonna
Yeah.
come tomorrow. You're there tomorrow.
Yeah.
1 to 4.
I'll be there 1 to 5. But somebody else's signature, not mine.
Oh, okay.
Yeah.
It was one of them that I had.
Just have them look it over. It's fine. Yeah.
I get a picture of the property.
Yeah, go ahead. I didn't finish it yet. Excuse me. Thank you. But to be honest with you, any questions that y'all might have got wrong on that probably is because y'all didn't get to the homework part of it yet. Don't mean that y'all don't understand. Just need a little practice. That's all. Yeah. All right, you good? I can take it down?
No, that's the whole problem.
Yeah, that's it. Oh, the whole problem? Like you want to make it smaller? I got you. That's the whole thing right there. Dang, it was 2 steps. Well, that's easy. Yeah.
That's because we didn't. Yeah.
Yeah. All right, cool. So, but it's not for y'all. That's for the people on the recording. So, for everybody on the recording, have a good night. See y'all next time. All right.
I'm not gonna say.
Not for us.
Bye.